Welcome to probability simulation. A probability simulation is just a procedure in which we're going to set up a model that will simulate a real life situation. So if you don't want to do something, maybe you don't want to have people smoking a cigarette, or you don't want to have somebody have 10 children in order to see what the probability is of getting a certain number of girls or boys, you run a simulation to mimic that using a random digit table. So again, a probability simulation is a procedure in which you set up a model of chance process that mimics or simulates a real situation. We can do a simulation also to represent events that might take a while, like for example, having multiple children, be too expensive, or things that you don't want to occur. Like for example, you want to find out what's the probability of having an accident. You don't want to have people have accidents just to find that out. So you'll use a simulation to mimic how that would occur. And we are going to use the random digit table to simulate this process. Okay, so how to run a simulation. So in order to run a simulation, we're going to do 4 steps. The first is to decide what numbers you're going to use. You're going to assign these to the outcomes. So we're going to figure out what the probability is of each event occurring, and then we're going to figure out which numbers we have to assign to them. And they're either going to be single digits if you have only 10 events occurring, or they're going to be, or less occurring, or they're going to be double digits if you have 11 to 100 options. And then number 2, where did you get your numbers from? We are all going to use the table of random digits. Number 3, tell when the trial will end, exactly what you will measure at the end of each trial. So you're going to basically tell me how you know a trial is ending. How are you going to group the numbers from the random digit table together? And how do you know when the trial ends? And 4, how many trials will you run? How will you find the final probability? So the trials you're going to run are just going to depend on how many we tell you to do. Like with any probability, the more trials you do, the better. But because of the screen size for right now, we're only going to do 10 for right now on the videos. On your homework or your notes, you might have more depending on the problem. It says how many trials will you run, and then how will you find the final probability? That just depends on the question. Here is our first problem. It says you want to find out the probability that a family of 4 children, there are exactly 3 girls. So we're going to do 10 trials. Remember, 10 trials is probably not the best number to do, but we're kind of crunched for space on this. So you've got 2 options. You have boys and you have girls. And the boys and the girls are 50-50. So you can assign them any way you want. Since it's 50-50, I would use the number 0, 1, 2, 3, 4 for boys, and use 5, 6, 7, 8, 9 for girls. And you can do it the other way as well. You can use 0 through 4. Oops, hold on. I'm just trying to erase this and make it neater. You can use the numbers 0 through 4. I could have made this girls and this boys. It doesn't matter. But you have to tell me what you're assigning them. So half of my numbers are assigned to boys. Half of them are assigned to girls. So if I've got girls, we're just going to make it a 50-50 break. So we're going to use the random digit table, and we'll know the trial ends. Now, we want 4 children. We want to mimic 4 children. So basically, we're going to stop after 4 numbers. So every 4 numbers, every 4 single digits on the table is when it will end. And then we're going to do 10 trials. Okay, so here is how we're going to do it. So trial number 1, we're basically going to start with the first line, and we're going to go through the first 4 digits. So the first trial, we have 0, 1, 5, and 8. So we have 0, 1, 5, and 8. That's where I'm stopping. Oops, let me make this a thinner pen. Okay, so 0, 1, 5, and 8. And then my trial 2 is going to be, oops, and let's go back on that. And if you remember, the numbers 0 through 4 were boys, 5 through 9 are girls. So in this first grouping, we have 1, 2 girls. So there's 2 girls in this one. Second one, we have a 1, a 3, a 6, and a 0. That ends right here. So we took basically the next 4 numbers, 1, 3, 6, and 0. And if you look at 1, 3, 6, and 0, the only one that's a girl for this is the 6. So there's only 1 girl in this group. Next group is going to be the 0, 1, 1, and 5. So 0, 1, 1, 5. And within that group, only the 5 is a girl. So there's only 1 girl. Ooh. Let me make this a little neater. 0. Okay. Then the next group is going to be the 8, 9, 2, and 5. So 8, 9, 2, 5. That one has 1, 2, 3 girls. And then next group, 7, 6, 2, 1. And within that group, the 7 is a girl, the 6 is a girl, so there's 2 girls in that group. And then we're going to keep going. 8, 5, 2, 3. So my next 4 children are an 8, a 5, a 2, and a 3. Sorry, I think I said 4. 8, 5, 2, and 3. So there's 2 girls in this group. So there's 1 here, 1 here. So that's 2 girls. And then my trial 7. Now, you notice that, you have 1 left here because this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There's 25. So, you can start with a 9 and go to the next line, or you can just ignore the 9 and just go to the next line, because if this is completely supposed to be random, you can just go to the next line and pick it up if you want. Or you can start with a 9 and continue on. I'm going to go ahead and just start on the next line so I don't have to worry about that, and I'm just going to go to the next line just to make it easier. So I'm going to have 0, 2, 9, 7. That's going to give me 2 girls. And then if I go to the next set right here, let's make it red, right here, that's a 2, a 5, a 6, and a 1. That will give me 2 girls. And then 7, 7, 8, 7, that's going to give me 4 girls. And then for the last one, I have 5, 8, 0, 6. That means I have 3 girls. So my question was, what is my probability of getting exactly 3 girls? So if I'm getting exactly 3 girls, that means I have 1, 2. So my probability, let me use a pen. My probability of getting exactly 3 girls is 2 out of 10 or 1 out of 5. Now, if we had phrased this differently and said what's the probability of getting at least 3 girls, then I would use the 3, the 4, and the 3. So it would be 3 out of 10. Okay, here's our next problem. In a game of Scrabble, each player begins by drawing 7 tiles from a bag containing 100 tiles, 42 vowels, 56 consonants, and 2 blanks. So Mary is shocked when her 7 tiles are vowels. Should she be shocked? What's the experimental probability of this happening? Now, here, what you need to be careful of is if you have 100 tiles, you don't want to start with 1 to 100 because that's 3 digits. And on the next page, you'd have to do 3 digits. So I'm going to do 0, 0 to 99 for my numbers. So for my vowels, I'm going to do 0 to 41 because if 0 is in there, that, I'm not spelling vowels correctly. That's my vowels. And then for 42 to 97 is going to be my consonants. And then my 98 and my 99 are going to be my blanks. Okay. So this means now I have to basically group them every two numbers and see if I'm going to have vowels. And since there's 7 tiles, your trial is going to end, so you have 2 numbers for each tile to represent each tile, times 7 tiles means you're basically going to stop at 14 numbers on the chart. Okay, so I'll kind of show you what that means on the next page. Okay, so for this trial, I'm going to do something a little different. Since you need 14 numbers, there's 5 in this group, 5, 10, 15. So every 3 columns is 15 numbers, but I don't really need the last number. So every 3 columns, I'm going to just get rid of the last number. So it's just a little bit easier for me to not have to like recount. So I'm going to basically going to get rid of this last number, this last number. This is random, so it really doesn't matter if I do this or not. Okay. So now we're going to go look at trial 1. So trial 1 is 25. So if you remember, the ones that I want for my vowels, I want to know what's the probability of getting vowels, and that was the number 0 to 41. So I'm going to basically look on here for, oops, let me make my pen a little thinner again. For my numbers, so I'm going to go back and look at these. So 25, 83, 76, 88, 21, 66, 42. So I've got 25, 83, 76, 88, 21, 66, 42. And if you remember, the ones that we wanted were our vowels. And we wanted the numbers 0 to 41. So that's this number, and that's it. So we only have 2 in this group. Then for trial 2, we're going to come over here and do this next one. 20, 49, 68, 48, 43, 18, and oops. Let me erase this and make this a little better so I can see that one. And let's go back up and get rid of this last column. Oops. Let me undo that so it's a little easier. Oops, I need to redo this one too. I didn't do these columns very well. Okay, it won't let me erase it. Okay, there it goes. My pen wasn't letting me erase. I probably made the marker too thick. So let me try this again. So 0, 6, I'm getting rid of this column. I'm getting rid of this one and this one. That's a little bit better. Okay, so trial 2, now we have 20, 49, 68, 48, 43, 18, and 36. And on that one, we have a 20, we have an 18, we have a 36. So there's 3 numbers in this group that are 0 to 41. Trial 3, we're going to come up here and do 91, 25, 29, 91, 34, 48, and 93. So we've got 91, 25, 29, 91, 34, 48, and 93. And that, oops, I need a highlighter. Okay. Then that's a 25 and a 34. And, oops, and one's at a 29. Yep, and a 29. So there's 3 in this group. And then I'm going to keep going. So I'm going to go to the next one. 99, 53, 82, 11, 69, and 41. So you can even, if you want to try to just highlight up here if you can. It might be a little bit harder like if you're on a computer, but I'm just going to write them all down. So trial 4, oops, need my pen, is a 99, 53, 82, 11, ooh, wait, let me do that over. I think I missed some numbers. Let's try that again. Okay, 99, 53, 82, 11, 69, and 41. 1, 2, 3, 4, 5. Okay, I want to make sure I had 7. And then I need a 9, a 41, an 11. So there's 3 numbers in this group. So I'm going to keep going. Trial 5. Okay, so I'm not going to use this last column over here. So I'm going to go on to the next row. So I'm going to go on to this row. So 38, 91, 48, 27, 7, 24, 76. So I have 38, oops, that's a 3, 38, 91, 48, 27, 07, 24, and 76. That means I have 1, 2, 3, 4 numbers in this group. Next one is 72, 02, 65, 81, 34, 93, 36. And that is from this group. 72, 2, 65, 68, 13, 49, 33. Oops, that's 30. Oh, wait a minute. Let me do it again. 72, 2, 65. Oh, I need to fix this. I messed up on some of them. So 65, so you got to be very careful. So 65, 68, 13, 49, 33. Okay, so now I have 2, I have 13, I have 33. That's 3. Then next row is this one here, 71, 76, 70, 44, 74, 32, and 90. So after you do these a couple times, I'm just going to go write down the ones that I have on here. So 71 is not a vowel. 76 is not a vowel. 70 is not a vowel. 44 is not a vowel. 74 is not a vowel. 32 is a vowel. So we have the number 32 and not 90. So we only have 1 in this group. Next group over here, we have 74. 16 is a vowel. So we have 74, 16, 25 is 1. And then we have a 4 and a 4. Okay, so they do sometimes have more than 1 vowel. So I'm going to put down this 4 twice. 1 for this 4, 1 for that 4. Because in Scrabble, sometimes they do give you the same number twice. There's 100 letters. So some of them are repeated. And then after 4, we have 68 and 56. Those are not vowels. There's 1, 2, 3, 4. There's 4 vowels in here. And then trial 9. We're going to go, let's see, down to the next line. we're going to go down to this line down here. So we have 4 and 7. So we have 4 and 7. Let's see. Let me see what the next ones are. So 4, 7. So we have 4, 0, 7, 0, 6, and 0, 6 again. So we have 2 0, 6s. Then, so we, again, 4, 7, 0, 6, 0, 6. 81 is not 1. 64 is not 1. 29 is. So in this case, we have 1, 2, 3, 4. We have 5. Now I'm going to go to, this one up here, 26. I'm just going to highlight. So 26 is 1. 90 is not. 56 is not. 56 is not. 17 is. Let me undo that. I think we got too far. So 26, 90. 56 is not. 56 is not. 17 is. 76 is not. So 17 is. 76 is not. 3 is. That's kind of hard to see on that one. The highlighter is a little harder to use. 3. So we have, for trial 10, we had a 26, we had a 17, and a 3. So this one, there's 3 of them. So on this one, if they wanted to know, okay, so the problem was, it says, should be, what's the experimental probability of this happening, that she had 7 vowels. If you notice on these, the probability, this one there is 2 vowels, 3 vowels, 3 vowels, 3 vowels, 4, 3, 1, 4, 5, 3. So nowhere ever in any of these trials did we have 7 vowels. So my probability, so my probability of getting 7 vowels from this experimental probability is 0 out of 10. At no time, so your probability of a vowel of 7 vowels is 0 out of 10. It's not going to occur based on this probability. So that was probably just a freak. So probability 7 vowels. Okay, that pen's probably a little too fat, but is 0 out of 10. At no time in these trials. Now, if we ran a lot more trials, we might get one, but in these 10 trials, we did not have where they got all 7 were vowels. Okay, so Miss B has 45 students, 12 girls and 33 boys in her stats class. She randomly picks 2 of them to get a bonus. What is the experimental probability in 10 trials that she will pick 2 girls? So we're going to assign, say, for example, girls the numbers 1 to 12. Since we don't have 100 students, we don't have to start with 0, 0. You only have to start with 0, 0 if you have 100 students. So for boys, we need 33 of them. So we're going to start with 13, and we can go to 45. It doesn't go to 46, it goes to 45. Okay. And then we'll use a random digits table. Our trial will end. Now, if we want to pick 2 girls, that means we want to look at 2 students. So 2 students basically is going to be the equivalent of 2 digits times 2, because we need 2 of them. So every 4 digits is a set of 2 students. So we're going to do 10 trials. Okay, so with this one, if you remember, we are going to use 0 to 12 was girls, 13 to 45 is boys, and then anything that's 46 and above, we can't use. So I'm going to go through, let's see. So we're going to do basically every 2 and look at them and see if we can use them. And then I'll mark them at the end. So we can use, So we can use 70, oops, no, we can't use 73. Let me erase that. Okay, so I can't use 73. I can use 9, that's my first student. I can use 45. I'll go and mark all these in a minute. I can use 36. I can use 8. I can't use 58 because remember, anything that's 46 and above are not boys or girls, so we're not using them. So anything that's 46 and above, we're going to mark out. I can't use 94. I can't use 94. I can use 29. And I can use 27. Okay, next line. I can't use 74. I can't use 97. I can use 19. I can't use 48. I can't use 61. No 61. No 74. No 96. I can use 10. No 85. Next line. I can use 15. I can use 27. I can't use 56. I can use 25. I can use 32. I can't use 47. I can use 31. No 93. No 98. I can use 42. I can't use 54. I can't use 79. I can't use 61. No 74. I can use 11. No 56. I can use 12. 36. That's a 3. No 65. And I can use a 45. And then down here I can use 19. And we can reuse these numbers because you're just doing different trials. And 14, as long as they're not the same number within the same group. Okay, so now the question is they wanted to know what the probability is of getting 2 girls. So 9 is a girl, 45 is a boy, 36 is a boy, 8 is a girl, 29 is a boy, 27 is a boy, 19 is a boy, 10 is a girl, 15 is a boy, 27 is a boy, 25 is a boy, 32 is a boy, 31 is a boy, 42 is a boy, 11 and 12 are girls, 36 is a boy, 45 is a boy, 19 is a boy, 14 is a boy. So there's basically 0 girls, oops, not 0 girls here. This group has 1 girl, no girl, 1 girl, 0, 0, 0, 2, 0, 0. So if the question was, what's the probability of getting 2 girls in this group, we only had 1 set of that. So we have a 1 out of 10 chance of getting 2 girls.